Hello guys, very good evening to all of you. We're going to start this webinar now. So my name is Rahul Kumar. I will be the speaker for this Hadoop webinar for another next 1 hour. Today's webinar topic is top 5 Hadoop administration tasks. So today we are going to talk about what are the different top Hadoop administration tasks that we need to do on a daily basis. Let's say we have to do any which ways in the Hadoop administration. So you can view our Hadoop administration course on this link www.edureka.co/hadoop-admin. For any queries you want to ask, you can ask it from the Twitter handle at edureka.in or #askEdureka. You can also post your queries on Facebook on that/edureka-in. Okay, so for more details, any which ways, if you have any queries during the webinar or after the webinar, okay, or drop your queries in the questions window, and I'll be more than happy to answer all your queries. You can also raise your queries to, you can reach out to a sales team, and they will certainly be able to support all your queries. They'll be able to resolve all the queries which you have regarding this course. At the end of this webinar, you will have a short survey of three to four questions. Please do not forget to fill that survey, as it will help us certainly to improve our services. Okay, so let us quickly start now and understand what are the top 5 Hadoop administration tasks. So the objective of this webinar will be to understand how you will plan the Hadoop cluster. We'll also understand how we can build a Hadoop fully distributed cluster setup with the help of 2 nodes. We'll try to add one more extra node to the running cluster, and then we'll upgrade the cluster from version 1 to version 2. At the end of this webinar, we'll also try to understand how to achieve high availability in the Hadoop distributed file system by providing the active name node and standby name node. So these are the things that we are going to cover in this webinar. Yes, so certainly, Somen. So one important point that for any Hadoop administrator, okay, Java is not at all a requirement. Okay, the main prerequisite to become a Hadoop administrator is you should have good understanding of Linux. Okay, basics of Linux are also clear. If the basics of Linux are also clear, that's also fine, and you can develop your skills on job itself. But Linux should be a prerequisite. Linux is a prerequisite for becoming a Hadoop administrator. Okay. Uh, After that, it's all about like understanding of Hadoop and its ecosystem component, not only the Hadoop but also its ecosystem like Hive, HBase, Pig, Flume, Scoop, Zookeeper. All such kind of components are also there in the big data administration tasks that you need to perform on a daily basis. Okay, so for a prerequisite, I will say only to have a good understanding of Linux system, and that's all. I mean, after that, it's all about how much you have learned around Hadoop. So today in this webinar, that's what we are going to do. We are going to just check out like some of the administration tasks that you guys will perform, that every Hadoop administrator has to perform uh, during the administration activities and during the job. So first of all, let us understand about the cluster planning that anybody has to do. So for a Hadoop cluster, to plan a Hadoop cluster, you need to think about 3 things. Okay, whether it is a single node cluster or is it a small cluster which you want to start with? Is it just a POC, or are you guys going to create a production cluster, large cluster, where you have already decided whether the cluster is like more about the computation power, you need more computation power, or memory, or data? So according to your use case, you can decide on the cluster build, and then you can build your cluster, where the configurations, the typical use case of a Hadoop cluster is that the master nodes which are there on the Hadoop cluster should have more memory. It can have less hard disk as well, but it should have more memory, more redundancy in terms of Ethernet cards or power supplies, and processor, and data nodes, where the data nodes will have more hard disk size, means the storage power, it should have more storage power, and it can have less memory as well. So it can have less memory but more storage, while it's vice versa in the case of master nodes. So when we talk about Hadoop cluster, the typical use case, the idea is that all the master nodes, okay, because master node is something in Hadoop cluster which if it goes down, it can bring down the whole cluster. Okay, your cluster can go inaccessible if the master node, if the master server itself goes down. So uh, uh, it's always important to take care of your master daemons, master processes, that they should not go down in any of the cases. Okay, so when we talk about, when we plan a Hadoop cluster, this is one of the very good methods to use to plan a Hadoop cluster. Okay, high availability is certainly possible, Somen, but not for all the components. Okay, however, in today's world, high availability is totally possible. Okay, but high availability is again, like, again, just to have got one active and one passive node. Okay, so what happens if both the nodes are also down? Okay, you don't have multiple slave nodes, multiple masters, something like that, right? So that's what the thing is. So you need to take extra care of all these things, okay, when you're planning your Hadoop cluster, that the master node should have more redundancy in terms of hardware. Okay, because hardware is always going to be the culprit for your Hadoop cluster. So seeking cluster growth on this basis of storage capacity is often a good method to use when you're building your Hadoop cluster. So just taking an example here, let's say your data is going by approximately 5 terabytes per week, and you have a replication factor in the data which is like set to 3 times. Now this is by default. You can always increase or decrease it, but let's say the default value it is taking, and your replication factor is 3, which means you need 15 terabytes of extra storage space required per week. So now if you assume that, if you think that, okay, your each machine has got 5 hard disk drives, and each the capacity of each hard disk drive is 3 terabytes, then it means you need 15 terabytes of storage space every week, and you need one new machine for that. Every week you need one new machine, which means you can decide, like, okay, for next 52 weeks, or next total year, full year, I am looking for at least 50 to 60 more machines. So you can decide your cluster growth based upon your storage itself, how the data, how the capacity of the data is going to come in the next coming weeks or next coming months or years. And accordingly, you can decide the cluster growth, and you can decide your cluster capacity. So if we talk about the cluster, nodes, okay, there are two types of node in the Hadoop cluster. One is the master node, and other are the worker nodes or slave nodes. Okay, so if Hadoop says that my slave nodes are bound to get failed, I mean, I'm expecting that my slave nodes will fail at some point of time because of a lot of processing and a lot of storage on those nodes. So uh, let's do one thing. Let's buy more nodes. Okay, might be fewer, slightly faster nodes. Okay, I mean, might be it can be of low capacity. That's fine. But buy more nodes so that it can bring more distribution power. Okay, more the distribution, less the pressure on those nodes. So general configuration, if you talk about the slave nodes, is just 4 into 1 or 2 terabyte of hard disk drives in the just a bunch of disk configuration, where there is no RAID and 24 to 32 gigs of RAM. While the special configuration, which actually generally works well for many types of application, is one hard disk drive with one hard disk drive with 2 core processor and 6 to 8 gigs of RAM. So the idea is that you can have, I mean, it's quite fine if you have more number of nodes, because they sometimes performs better than one with fewer, slightly faster nodes. So it can be either way, but the thing is, if you're using the latest workloads like Spark, Impala kind of workloads, certainly you should have some good configuration in your cluster. Now, this is the recommended configuration for your slave nodes. What about the number of tasks that you're going to put on each slave node? So Hadoop says, okay, each of the mapper and reducer task can take 1 to 2 gigs of RAM. I mean, that is the approximate configuration values for the memory. So each mapper or reducer task will take 1 to 2 gigs of RAM, and they should not be using any virtual memory, uh, because virtual memory requires the usage of disks. Okay, so disks certainly, I mean, should not be used, because it is used for only the storage. Okay, now if we take some memory for your data node daemon, task tracker daemon, or for the operating system, then take it out, take that enough amount of RAM for them, let's say 2 gigs of RAM for each of these daemons. And the rule of thumb says total number of tasks, total number of mappers plus reducers is equal to 1.5 times the number of processor cores. So if you have a quad core processor with hyper-threading enabled, which means 1.5 times number multiplied by 4 multiplied by 2 is equal to total number of tasks divided into the ratio of 2:1, and that will be your total number of tasks on each task tracker node. So for each task tracker node, you can easily find out the total number of tasks and divide it into some ratio for mappers and reducers. So you can tune your slave nodes like this. So in the Hadoop cluster, there are always going to be two types of nodes. One is going to be master node. Master node means which is going to consume all the metadata which is being stored in the Hadoop distributed file system. And second is the slave node, which is going to store the actual data in the form of blocks. And combining both of them, combining both the master and slave node, you get the Hadoop distributed file system. So HDFS has got two types of nodes. One is the master node, which in Hadoop's world is called name node, and slave nodes, which in Hadoop world is called data node. Name node stores the metadata, which is very critical for the data to be recognized in the Hadoop distributed file system, and data node, which contains the blocks of the data, which is again very critical to find out to get the data from the database. But data node are again still not that critical because HDFS has a replication factor. It has already got some fault tolerance with the help of replication factor, which means by default, if you are going to store 1 gigabyte of data in the HDFS, automatically it will be replicated to 3 nodes with 3 times. It is going to replicate 3 times into 3 different data nodes, which means if one of the data node goes down, the data can be fetched from the other data node. So the idea is the HDFS is again fault tolerant. It is more. It can be scaled as well. You can always add more nodes, delete more nodes from the cluster. But master nodes are always going to be very important. They are going to be one per cluster, and hence you should always put more redundancy from the hardware level as well as software level into the master nodes. So that is why the hardware configurations, hardware recommendations for master nodes are always like multiple. So do not use any commodity hardware, do not use the cheap hardware for that. Always use enterprise level hardware, carrier class hardware, at least 32 gigabytes of RAM, which means, I mean, 32 is just the starting, I would say. I mean, in today's world, it can go to 100, 200 gigabytes of RAM as well. Rated hard drives, because there is no fault tolerance in the name node master node. Dual Ethernet cards, which are channel bonded to provide the failover, and dual power supplies. If one of the power supplies go down, another can take over. So you can differentiate here from the between the master and the slave nodes. Master nodes, they should not get failed in any such cases unless there is some natural disaster, which can always be possible. Okay, but in that case also you can always plan for the disaster recovery as well. Okay, that's certainly a bit of out of the scope for now, but yes, you can plan a disaster recovery as well for your cluster. So if we talk about the Hadoop fully distributed node cluster, okay, this is how you will plan. I mean, you can use these commands and the root privileges. You can open some ports. You can disable the IP tables if required. You can run some Hadoop applications. You can just simply turn off IP tables or open these ports, like these are the default ports of the Hadoop cluster. Now there are 3 modes in the Hadoop cluster. Okay, one is the standalone mode where there is no Hadoop daemon, which basically do not use in the organizations. It is just required for the cluster. I mean, debugging purposes. Pseudo distributed node cluster, which actually is an imitation of your fully distributed node, which is being used in the production architecture. So fully distributed mode says that all of the Hadoop clusters, Hadoop daemons, Hadoop processes are going to be run on a cluster of machines. It can be 2 or more than 2 nodes. It can be 2 or more than 2 nodes in one cluster. So guys, no need to raise hands. Okay, if you have any queries during the webinar, nothing, you don't need to really raise hands. You can just drop your queries into this questions window, and I will resolve them during the webinar itself. Okay, if there are any unresolved queries, okay, you can reach out to our sales team and they will certainly resolve all of your queries. Okay, so no need to really raise hands, you just can drop your queries into this question window. So this is how you will get your, different modes in the Hadoop cluster. Okay, but we are going to do today, we are going to create the fully distributed node Hadoop cluster. And the next important thing is the passwordless SSH key. Now, passwordless SSH key basically requires, the public key to be added into the authorized underscore keys file in the nodes, in the master node. Okay, so we're going to create that as well. Okay, so that master nodes can connect to the slave nodes without any asking any passwords. And these are some of the configuration files that we need to edit to create this Hadoop cluster. Core site, HDFS site, yarn site for all the configurations for Hadoop daemons and its processes, mapred site, and slave file and Hadoop environment, yarn environment site files for the uh, data node and the task tracker machines. Okay, so these are some of the configuration files that's how we're going to edit today. dfs.data.directory, HTTP address, default file system for your Hadoop distributed file system. And what we're going to do now, I'm going to just show you like how I have done here. I've got basically 3 nodes here. Okay, where I'm going to start 2 nodes as on the Hadoop cluster side. So this is my one of the node. Okay, this contains, the idea is that it will have it will take all the Hadoop daemons, and I've got another node as well, which is your data node that will contain only the data node specific daemons. So I need to first format the Hadoop cluster. Once it is formatted, once the Hadoop distributed file system is laid out in the Linux file system, after that you need to just start the daemons. Now to start the daemons, you need to run the command start dfs.sh. Okay, so we need to start the distributed file system daemons like this, which is going to start all the daemons, and then start mapred.sh for basically starting all the MapReduce specific daemons, job tracker and task trackers. Now, once this is started, you can use the Java processes command to see all your Hadoop daemons. Like you can see a job tracker daemon coming up, secondary NameNode daemon coming up, NameNode daemon coming up, task tracker daemon coming up, and data node daemon coming up. And the same thing you will see on the other data node as well, where the other data node will have the data node and the task tracker daemon. So the idea is both the nodes are having the Hadoop components, Hadoop processes running up. Okay, right. Is it okay? Okay, I just got one comment here saying that there is some disturbance in the audio. Is it still like that, guys? Is it still disturbance? So how about now? Is it okay now? Oh, is it? Okay. Yeah, just a sec. No worries. That's fine. I think it's not the internet. It's about the machines. Actually, it's a lot of virtual machines I'm running today. So that's the problem. That's fine. No worries. Yeah, just a sec, guys. Just a sec, please. Okay, just give me a sec, please. Just give me a sec. Let me make one setting here. Okay, so I hope that it should be fine now. So is it okay, guys, now? Right. Okay, my apologies for this small disturbance in between. Okay, let's continue. Okay, so what I have done here is I have created, the 2-node cluster, fully distributed one. So these are the daemons running currently on my node, and I have got another node as well that's also running 2 of the Hadoop daemons. So this actually shows your Hadoop cluster with all the processes, and you can see the same thing from the web interface as well. If you go to the web interface and check out the process is running of the Hadoop daemons. The name node is, you can see, up and running currently with two live nodes. Two live data nodes are there, and the same thing you can see for the job tracker as well, which is going to allow you to run the jobs in the cluster. Okay. Now these are your job tracker specific things. Okay. So this is how you can build the cluster, and on the fly, let's say if I'm already running one cluster and I want to add a new node in the cluster, how is it possible? How we can do that actually? Let us see that as well. So what I've done here is I've got another node. Okay, so that node is new DN, new data node. Okay, so currently there is nothing on this, no process is running on this particular data node. What I want to do is I want to add this node as well into my cluster. Okay, so currently only two data nodes are available. Okay, what I want to do, I want to add a new data node into my cluster so that I can scale my Hadoop cluster. I can bring more storage. So what I need to do for this thing, I need to make a small change. I need to do SSH copy so that I can have a passwordless SSH between the new data node. You can see without any passwords now I can do an SSH into the new data node. And the next thing what I need to do is I need to add into one file called includes file. I need to add this new data node called newdn.cluster.com. Once this node is added, I need to just run the command hadoop dfs admin hyphen refresh nodes and hadoop mradmin hyphen refresh nodes. Now once it is done, I can see that the new data node is now coming up. It is now showing up at least into my cluster. I can see this new data node here. But the challenge is right now that it's not able to, I mean, it's not coming up. It's dead node right now. It is showing as one dead node. Okay. So what I need to do here, I need to just log in into this new data node. And what I need to do here is I need to create one directory like this. I need to change the permissions to 755. Okay. So I have created one directory, data directory basically, and I have changed the permissions to 755. That's all I need to do. Okay. Yes, so man, like this only. So if once you do this, and now if you on the new data node, if you start the Hadoop daemons, start data mode, you need to certainly have the binaries of Hadoop in the new data node. Like in this case, you can see I have got Hadoop binaries. Now once these daemons are also up, you can see data node and task tracker are up on the new data node. And if I now go to the name node and do a report check whether the new data node has been added or not, you can see that now the third data node is also added on into my cluster. Okay, this way I can add a new data node. I can scale my Hadoop cluster itself. Okay, so some tweaks of the configuration. Okay, some understanding about how actually this process works, and then I mean it's all about running the commands, and you will be able to scale the Hadoop cluster. So that is one of the things that you can do in the Hadoop cluster, and that actually is required on a I mean I can say that on a weekly basis. This is always expected from a Hadoop administrator. Okay, adding some nodes, removing some nodes, understanding what if the cluster is balanced or not. Okay, how to balance the cluster. All these things certainly will add up to the uh, the things, the task which a Hadoop administrator has to do uh, in the Hadoop cluster. Okay. Well, it depends. So, man, certainly it depends upon the data capacity, how your data is going to reach, how much your data is going to get added into the Hadoop cluster. As I just told you, what is the good method, what is the best method to build the Hadoop cluster. Okay, but yes, it can be. Yes, it can be certainly possible that every week or every fortnight, I mean, you need to add a couple of nodes or decommission couple of nodes from the cluster. Yes, certainly. So now the next thing which a Hadoop administrator certainly has to perform is the upgrade. Okay. Why decommission? So decommission are required, Sumin, because let's say your hardware of one of the data node has gone down. Okay. I mean, I have seen a lot of issues going into the hardware, even if you are using the Red Hat kind of operating systems and HP or Dell kind of hardwares. Okay. Even a minor glitch can bring down your whole node itself. Okay. So that way it is quite possible that you need to decommission that node from your Hadoop cluster. Another question, how long usually we store the data? Is it for some period, say 6 months or so? Well, you can store it for years, Nabanida. Okay, it's not at all really uh, that you need to remove the data. Okay, you can use it, you can store your HDFS data for as long as you want into your Hadoop cluster. There is no foundation of that. Okay, guys, any issues in the audio now? Any problems you're facing now? Is it clear now? So guys, any issues in the audio? Okay, okay, cool. So the next step that a Hadoop administrator has to perform, okay, is the upgrades. Okay, how will you do the upgrades in the Hadoop cluster? So let us understand that as well now. Now, upgrading basically requires there are two types of upgrades. Okay, minor upgrade. Okay, where you want to move from 1.1 to let's say 1.2, 2.2 to 2.3, something like that. Okay, or you want to do a major upgrade, let's say from version 1 to version 2 itself. How will you do that kind of upgrade? So today we are going to check out the major version upgrade. I want to upgrade from version 1 to version 2. Okay, so let us see the process how you can actually do the upgrade of this Hadoop cluster. I'm sure, yes, Richa, I think you will get the recording of this particular webinar, certainly. Yes, Prasanna. Okay, there. See, capacity planning is more about how you plan your cluster, what kind of data is okay, how much, what is the retention period of data, what are the data sources, how long you want to keep the data, how long you want to process the data. Lot of factors are there to do the capacity planning in the Hadoop. One thing is you should be always sure of that the storage is cheap. Okay, do not really worry about the storage at all. And once we are saying that it's a big data, certainly you are not going to store the data in just gigabytes. Okay, it will always go into some terabytes only. And Hadoop nodes, I mean, they are always going to be very big. Okay, every node might be storing like 12 to 14 terabytes of data, and then probably your cluster will be having like 600 700 terabytes of storage. So that's quite normal in a Hadoop clusters. Okay, having a cluster of 70-80 nodes is quite normal. Okay, a lot of organizations starts with 30 40 and grow up to 100 nodes. Okay, what I'm trying to say is capacity management it has a lot of factors involved. Okay, before you can decide what kind of nodes, what kind of a cluster you want to build, what kind of capacity you want to have in your cluster. I have come across 800 node cluster, Somen. Okay, but I have seen a 2000 node cluster max. Okay, however, a single Hadoop cluster with just one master node can easily accommodate 4,000 data nodes, and the largest cluster on this planet has got 35,000 data nodes. Okay, of a Hadoop cluster. So it's going to be huge. I mean, it's a huge thing, certainly. Okay, so let us see the process now. How we can actually plan for the Hadoop upgrades. Now, when we talk about the Hadoop upgrade, okay, we always need to be sure of what we are trying to upgrade. Okay, is it the Hadoop binary? Is it the Hadoop processes? Is it the Hadoop libraries? Okay, what actually it is. Now, when we talk about the Hadoop upgrades, major version upgrade from version 1 to version 2, okay, it's going to upgrade certainly couple of things. Okay. Uh, First is that you want to upgrade the, it will certainly upgrade the Hadoop binaries from Hadoop version 1 to Hadoop version 2. And second thing, it is going to upgrade the distributed file system. Okay, it is going to upgrade the distributed file system because you already have got the MapReduce, okay, which is being changed, which is being upgraded in the Hadoop version 2, and it is about the yet another resource negotiator. It is about the yarn, which you can actually create a new, MapReduce itself in the version 2. So what we are going to do today, we are going to upgrade the Hadoop distributed file system from version 1 to version 2. Okay, right now I'm working on the Apache Hadoop, guys. Okay, basic plain vanilla Apache. Okay, where you need to do everything manually. Okay, that's what I'm running right now. So here what I've done is I have got both the Hadoop versions, Hadoop version 1.2.1 and Hadoop version 2.2.0, which what I want to do is I want to upgrade from version 1 to version 2. So first of all, what I want to do is I want to format the name node for version 1 and start the daemon, so that it's like the prerequisite of upgrading is that you should have a running Hadoop cluster with no issues. Okay, no issues in the daemons or processes. So I am now going to just start the MapRed daemons. So this is my currently running Hadoop version 1 cluster. You can find out the version by running the Hadoop version command, and you can see the Hadoop processes as well by running the simple for loop. You can see that currently it is running with the name node, job tracker, secondary name node, data node, task trackers, daemons on 3 data node. Basically, it's a 6 node Hadoop cluster which I'm going to upgrade today. So now what I was talking earlier, that we want to upgrade the Hadoop distributed file system. But so to upgrade the Hadoop distributed file system, I need to know the what is the current version right now and what is the to be version. Okay, so the version right now which Hadoop distributed file system is using is, let's see, this is the layout version. This is the version of Hadoop distributed file system for right now. Okay, so what I want to do is I want to upgrade this layout version from -41 to some other version which Hadoop 2.2.0 has. Okay, so first of all, just to test out my cluster as well, I'll create an input directory. I'll run some, I'll put some data. Okay, I'll run a MapReduce job so that it can generate some output data as well. So it's going to run a no, we do not really format the name node at all, Pranay. So format command you use only once in a lifetime of the Hadoop cluster. Okay, never during the upgrade, never at any point of time. Okay, you don't really do the format command in the name node at any point of time. Now once your job is successful, you can see some data in the output directory. So what we want to, what I was trying to do here is I just want to make sure that once the upgrade is successful, all my data should be there in the Hadoop cluster. So what I will do now, I'll do some format. I'll take some backup here. So this is how I'll take the backup. First of all the file system metadata, and then the recursive list of files that my Hadoop nodes have, Hadoop distributed file system has, and then the report of the Hadoop cluster. Once this backup is done, what I need to do is I need to stop the MapReduce daemons. So I'll go to the job tracker. I'll stop the MapRed daemons first, and once they are stopped, I just want to verify. So I'm stopping all the daemons for now, and I will install the newer version of Hadoop. So you can see currently no Hadoop process is running as all the processes are stopped. Okay. What I want to do now, I want to install the newer version of Hadoop. Now with the scope of this webinar, I've already configured the newer version of Hadoop, and what I want to do is I want to install the newer version. So I'll just point my binaries to the newer version, and once it is done, I'll run the I'll open a new session, let's say, so that my newer file can take effect. And if I run the command Hadoop version, okay, you can see it is now pointing to Hadoop 2.2.0. Well, that's the thing actually, Prasanna, it should be on all the nodes. Okay, same nodes on all the nodes. Okay, whether it is a name node, data node, job tracker, whatever it is. Okay. Now once it is done, I will run the command -upgrade, which will upgrade my name node first. Okay. Once the name node is upgraded, you can see now, you'll see now that it should change the name node file version. But currently you can see it has not changed the file system. Means there is some challenge, there is something that has happened which might has not. Okay, so it is actually changed now. Right, so it is changed actually. I think we were looking at this tail file. And you can see now the layout version has changed from -41 to -47. You can see I ran actually the commands earlier, but it showed me the stale file. Once the file system version is changed on this node, it will change it on all the nodes. Once I run the command start dfs.sh, so it is going to start all the Hadoop daemons, okay, and it will upgrade their file system as well. Now once the file system is upgraded, you can just go to the again you can go to the web interface and see whether the version 2.2, okay, you can see now version 2.2.0 is now up and running. Okay, and in some time it is going to bring all the Hadoop nodes as well, and you can see your secondary name node as well in the newer version. Right, so you can see now all the Hadoop nodes are here, 3 live nodes, 3 data nodes, sorry, three data nodes you can see, and all the data nodes are on version 2.2.0 right now, and secondary name node which is also on 2.2.0. So automatically they have also upgraded their versions. So upgrading the Hadoop cluster is not again a challenging task. You should have some understanding of internals, but how it works actually, what are the different directories, locations, how you will configure your upgrade and all. And once you are aware of, you can certainly easily upgrade your Hadoop cluster as well. So that's the another piece which I wanted to show you. And the last piece for the demonstration is about how you will create the put the high availability in the name node. No. So now it will just upgrade the name node only. Once I will start all the daemons, they will upgrade from the name node. They will take the upgrade from the name node. Okay. So they will automatically get upgraded. Okay. But once I just upgrade the name node, it will only upgrade the name node there. Automatically, it will not reflect on the entire cluster. What I need to do now, I want to show you the next important point, the last one, which is the high availability in the name node. So high availability is a process where basically you have got two types of name node, an active name node and a standby name node. Okay, where active name node is writing its metadata in the shared storage, and standby name node is reading some that metadata. So the idea is that if the active name node goes down, standby name node will become active, and automatically it will, because both are already in sync via this shared storage, automatically it will take the jobs from the clients. Means there won't be any hindrances in the jobs of the clients, of the users. So to bring this shared storage, okay, and to bring this synchronization between this active and standby name node, there are another set of daemons called Zookeeper failover controller. Zookeeper failover controller, as you can see what it is written over here, monitor the liveness and health, manages the high availability state. So it manages this high availability state and puts all the data into this Zookeeper service. So there is another set of daemons called Zookeeper, which is going to be used for storing the state of the highly available name nodes. So to bring on this architecture, what I have done here is I have got three different types of three nodes, two name nodes, one active and one standby, and one data node, so that I can check if the active goes down, I still have got that data on. Okay, so what I'm going to do now, I'm going to bring this name node up. Okay, Let me show you. So these are the 3 nodes which I'm running. No, it's deployed in the real life. Okay, it's not in POC mode at all now. Now this high availability is very typical actually to deploy. It's not that easy stuff. Okay, to understand it in detail also it's a bit typical thing. Okay, so I'm going to run a couple of steps here so that it becomes easy to deploy this. So first of all, I need to run the zookeeper. I need to configure the zookeeper. I'm going to go on all the nodes and configure the zookeeper. And once the zookeeper is up, what I need to do is I need to I need to start the journal nodes first. Okay, so I've written some of the commands here for the ease. Okay, as there are a lot of daemons involved in it. So you can see first it is starting the shared storage daemons called journal nodes. Okay, once the journal node daemons are up and running, I've got my shared storage with this. You can see 3 journal node daemons are now up and running. Once they are up, I can start the name node by first formatting it. And once the name node is up, I can go to the second name node and start the second name node as well. Now, from where you will get the idea that both the name nodes are in sync. Okay, this is the step. This is the important image that you can see here, which I've just highlighted. From where the logs you will get that okay, this name node, the second name node is fetching all the data from the name node 1. So what it says, about to bootstrap standby ID name node 2 means it is fetching the metadata to be in sync from the name node 1. So this is the name node 1. This is the location from where it is fetching all the metadata. So it will copy all the metadata, means you are not formatting the name node 2 at all. You just need to copy the metadata. So either you can use the simple rsync command as well, you can use the scp command as well, or you can use the Hadoop specific commands to bring this second name node. Now once these are up, so you can see the name node and journal node daemons are up and running. What you can do is you can start the zookeeper nodes. Okay, so zookeeper nodes are easier to start, and once the zookeeper daemons are up, you should be able to see the uh, zookeeper daemons. You can see currently they are not up right now, means there is some problem in the zookeeper daemon. You can go into the zookeeper out file and just check out what is the problem. You can see the problem is, it says reading configuration. So some problem in the configuration itself. My ID file is missing. Okay, so that is fine. What we need to do is we need to go into the each of the node and create the my ID files. So my ID files are required by the zookeeper, and let us start the zookeeper processes now. And now you can see the zookeeper process is also now up and running. Quorum peer main. So once the zookeeper processes are up, you need to start the zookeeper failover controller. So zookeeper failover controller is the one that is going to help you to keep the metadata in the zookeeper nodes. So we'll start the data node 1 as well, and now the zookeeper failover controller. So I know it's a bit fast here. I totally understand that. Okay, but the idea is just to show you once the high availability is being set up, you can check out this high availability easily by running the command get service state. You can see one name node is in currently active state and another name node is in currently standby state. So how can I find out, how can I do the testing for this, that if the active name node goes down, standby will become up? How can I do that, guys? Any ideas? How can we prove that it is highly available now? Can you think about something? Down the name node. That's right. Shut down the name node. Shut down the active one. So I'll kill the active one. Okay. I'll kill the process because that will be the ideal way. If during the name nodes running, if the active name node goes on, what happens? So I'll kill the process here. Once the active name node process is killed, you can see it is now not running. So once it happens, I can go to the name node 2 and run the get service state commands. You can see get service state of name node 2 is now active, while name node 1 is currently not reachable. You can see it's not reachable. However, if I just start the shutdown to NameNode, I mean, which is already stopped, if I start that, it will certainly come up, but now it will come up into the standby mode. Means it will not check, it will not hamper the process of NameNode 2. NameNode 2 will now be remain in the active state. So that's the way you can bring the high availability as well into your Hadoop cluster. Okay, data which is being stored in the Zookeeper. Okay, you can see that data as well. Okay, it stores some data. These are the two files that it use. Zookeeper failover controller uses actually to make the active and standby locks on these NameNode daemons. So these are some of the tasks, guys, okay, that you can that you need to do certainly in the Hadoop clusters during the administration activities. Okay. Uh, so what we do in our courses, okay, we have got like 8 classes. If you're joining a weekend course, every course is of 3 hours. Every session is of 3 hours each. Okay, these are all live online classes. When if I take those classes, I show everything online. I mean, I show everything practically, that how we have to configure this, how these things are working internally. All these classes are being recorded and being shared via the learning management system. And if you are facing any problems during the the cluster during the working in your clusters, we do provide the class support, okay, from our technical team, and post class support as well, which are working 24/7 around the clock for you guys. So weekend course basically is of 3 hours each, and 8 classes where each class the time of each class is 3 hours. And if you're joining a weekday batch, then it is going to be 12-day continuous classes, every day 2 hours class. Okay, every module has got quizzes and assignments. Okay, and at the end of this course you will get a project work which you need to complete to get the project based verifiable certificate, to achieve a project based verifiable certificate from Edureka. Okay, uh, if you have any questions regarding this course, regarding the webinar, regarding anything, okay, feel free to ask any of the queries right away. We do certainly we do have webinars for the development courses as well. Okay, reach out to our Edureka's homepage where you'll find out the information about what are the webinar details for the development course. Okay, uh, so what you can do, guys, okay, to get more details about this course, you can go to the page called edureka.co, www.edureka.co, like this, and you can just click on the, you can see right now itself on the home page itself. The second course is of Hadoop administration. The prices of this Hadoop administration course is also given, the number of learners and the batch details as well. So online classes 24 hours, assignment of 30 hours, project of 20 hours, and lifetime access to the learning management system. And the training details are given where the number of batches as well. So details of the batches as well are also being given here. You can see the early bird, uh, the discounts and all being presented here. So you can enroll for all the batches. You can see the certification things. You can see the curriculum of this course. You can see the all facts related to this course and the sample class recording. Okay, you need to certainly sign up for that. Upcoming batches details. All these details are being presented in this learning management system itself. So these are the course topics that we actually cover in our course. Okay, we do cover Hadoop certainly in length. Okay, while all the ecosystem components like major one, Hive, HCatalog, HBase, Oozie, Flume, Scoop, Pig, Zookeeper are covered as a basic part of this course. Okay, so I think this is all from my side. Okay, if you have any specific queries, please do not forget to fill the webinar survey, which you will get after you leave this webinar. And if you have any queries from your side, we still have got some time to I can answer your queries from the technical perspective as well as non-technical queries if you have any. Okay, anything about this course, anything about the frequently asked questions, okay, you can check out our frequently asked questions here. You can check out what are the system requirements to install the virtual Hadoop cluster. Okay, You can also check out the course reviews as well, okay, which are being presented by a lot of people. Yes, I do apologize for that, Rajat, for facing all these audio issues. Okay, we do not certainly face these. I mean, you are not going to face this during the webinars, from the next webinar, as well as in the courses as well. Okay, I am pretty sure that there was some Citrix glitch today, which has got this, in the webinar, and I sincerely apologize for that. Okay. But any other thing, do drop us a query. You can always do that from this module, from this particular page, as well as you can reach out to us with the help of these all numbers. I am a Hadoop developer. Do I need to know Hadoop administration as well? Well, from my side, Naba, if you're asking from me, okay, what I have seen is to become a good, if you want to have a good knowledge of Hadoop, okay, do learn Hadoop admin as well. Okay, Hadoop development is certainly a good idea to learn to understand the internals. Okay, but Hadoop administration will give you a lot of insights, which I have seen Hadoop developers they don't have. The reason is they are not aware of the architecture, the cluster architecture itself. Okay, they are not able to understand how can we utilize the resources of this big cluster. Okay, this is what they are missing. So they are only aware of the CPU and memory, which is again not really just enough to. I mean, you can build your program, you can build the code, but again the performance of that code will not come. Okay, so I would always recommend, I would always say that okay, learn the Hadoop administration if you are aware of Hadoop developer. And if you are aware of Hadoop admin, then it's certainly if it is your interest to learn Hadoop development or not. So it's vice versa is not correct actually. Hadoop administration, for a Hadoop admin to learn Hadoop development, it's a bit challenging task. But for a Hadoop developer to learn Hadoop admin is not at all challenging. Okay, and it's going to be more interesting. I can bet on that. Okay, you guys are going to find it more interesting than Hadoop development. So I think guys, if you don't have enough queries now, then that's all from my side today. Thank you all for joining in. We will certainly take care of all the audio issues from the next time. Okay, they will certainly not come up. And try to ask any queries if you have, okay, from our sales team. And if you have any other queries, do reach out to them, to call them or just email them. They will certainly get back to you with your queries. Thank you so much. Have a very good day, very good night. Cheers. Bye.